So last year we did some testing in the drop tower looking at the effects of knots in nylon and Dyneema slings, and we thought we'd extend that a little bit today to look at the use of slings in anchor points, whether that's on a belay or on a multi-pitch abseil, and in particular what might happen if you were moving around, maybe climbing above that anchor point and fell directly onto it. In these tests we are looking at a worst case scenario. We've got an 80 kilogram mass which doesn't fall in the same way that a human body does. A human body waves their arms around, impacts taken up by the movement of the harness, movement of the arms. We've also got a free-falling rig where if you were on a crag there's likely to be some sliding, some scrambling as you fall. So again, that would reduce the impact force. So we're going to look at some of the different setups that you can use a sling at an anchor point. Some which are reasonably good practice and some which definitely aren't, and we'll hopefully find out why those ones are not so good. So one of the setups we have is with a 120 sling clipped into the two anchor points, and then with a simple twist placed in the bottom and your carabiner clipped in here. So even if you move around, you can see that the load is spread to the two different anchor points. But a second system, which is fairly similar in that the slings are in the same setup, the difference being you place an overhand knot in the middle, and the knot is moved to the balance point of the two pieces of gear, and carabiner is then clipped through either side of the knot, and that's the essential point. Also, to see the effect of putting knots into the slings and the anchor points, we'll be doing the setup with clove hitches at the two anchor points and the central belay point, and also the same setup but with overhand knots used instead of the clove hitches. One further test will be using this 2mm cord to represent a marginal piece of gear, and we'll be repeating the full factor 1 onto this setup, which will hopefully result in the 2mm cord breaking, and we can look at what happens then. For all four setups, for nylon and Dyneema, we're going to be looking at full factor 1, which would be falling from level with the gear to below it, full factor 2, which would be from falling an equal distance above the gear to below it, and our final setup will be using two of our 8.2mm half ropes and clove hitching one rope directly into each anchor point. Now let's see what's going to happen. So with the self-equalising V, using a full factor of 1 and the 80 kilogram mass, we had impact force of over 16 kilonewtons. On the nylon, it was slightly reduced to 11.5 kilonewtons. The difference between Dyneema and nylon is that the nylon is slightly more elastic, it's got slightly more stretch than the Dyneema, so that explains the slightly lower impact force. When we did the factor 2 fall on these two setups, as expected, the impact forces were considerably higher. So on the Dyneema, we reached 27 kilonewtons, and for the nylon, it was 19.7. In both cases, the slings stayed intact, they didn't break, but the forces involved are extremely high. With the equalised V, with the overhand knot at the balance point, we had slightly reduced impact forces compared with the self-equalising V. This is explained by the knot in the system. As the load comes onto it, the knot will tighten and slip a little bit and takes a little bit of impact out of the fall. The results for the Dyneema one were 12.5 kilonewtons, and for the nylon it was 10.8. So as much as they are reduced, they're still very significant loads. As expected, when we did this setup with the full factor 2, the forces were much higher. They were lower than on the self-equalising version, again as explained by the knot, and the results we got were 15.5 for the nylon and 21.7 for the Dyneema. Still very, very high impact forces. On the two systems where we use the clove hitches and the overhand knots, where we have the knots on the two anchor points and the central belay point, the impact forces were significantly less, so both on the fall factor 1 and the fall factor 2. This is explained as with the previous method with the single knot. The 3 knots in the system, or 3 clove hitches, absorb the energy of the fall, they slip a little bit, which reduces that impact force. However, critically, on the Dyneema slings, by placing the overhand knot in the system, it does weaken the sling. So both on the fall factor 1 and the fall factor 2, we had the sling failing. On the fall factor 1, it was only half of it which failed, although obviously you'd still be fairly scared. And on the fall factor 2, it did fail completely. Using the self-equalising V, there was an initial peak of around 4 kilonewtons, at which point the red cord broke. The whole system then dropped, and there was a second peak of 14.9 kilonewtons. This is lower than on the fall factor 1. The difference here is that the load was spread between 2 anchor points, and it's now directly onto that second piece. So not only would it be an extremely unpleasant fall, it would likely lead to failure of this piece. So these are results for the self-equalising or sliding nylon when we had the piece of gear ripping. This initial peak here of just under 4 kilonewtons was when the red tap broke. We then go into free fall and have the second much higher peak when all the load came onto that second gear of, in this case, just over 10 kilonewtons. Here with the Dyneema in the equalised V and overhand knot, we had the same initial peak of around 4 kilonewtons, at which point the red tap failed. Again, rather than dropping, as in the last setup, we had a much more gentle swinging fall onto this secondary piece of gear. This meant the load here was considerably less. Additionally, we found that this knot under loading started to slip and slide a little bit, which took even more force out of the system. The resulting peak load was actually 4.9 kilonewtons. We repeated these two tests with the nylon sling. As expected in the self-equalising V, the result had a slightly lower impact force due to the nylon being slightly more elastic. Although interestingly, on the setup with the overhand knot, the load was slightly higher. This is because nylon is a less slippy material, so the additional slippage on this setup didn't occur with the nylon, so we had a slightly higher reading. In this setup with the clove hitches at the 3 points, we again had the initial peak when the red tap broke of around 4 kilonewtons. Similar to in the double equalised V with overhand knot, when this did snap, we had a relatively gentle kind of swinging fall onto this secondary piece. And again, similar to in the overhand knot one, we had slippage on the clove hitches here. So as the load came on, this slipped quite a lot, resulting in relatively low impact force of just over 5 kilonewtons. We did the same test with the nylon sling in the same setup. As the nylon is more dynamic, as I've said a few times now, the load was reduced to the stretching, but as it's less slippy, it didn't slide through on the knot as much. So we actually had the exact same reading, 5.5 kilonewtons with the nylon. Our final setup involved using 2 double ropes and clove hitching each one directly into the belay point. We then did the factor 2 fall onto this setup, and we had an impact force of 7.6 kilonewtons, which was, for the factor 2 falls, by far the lowest reading we had. This shows how much better the ropes are in that belay situation at absorbing the energy. If you are going to be setting up belays, ideally use your ropes to do it. If you'd like to use your slings to equalise some points, try and use your rope to clip into that central point on the sling. If you are clipped into a sling directly, really try and minimise how much you move around on the belay ledge, particularly if you start moving above your gear, where any fall could be, very painful and potentially result in gear snapping.